So, good morning everybody. Today we are all together at the Haydar Aliyev Center, the most valuable symbols of Azerbaijan. The slogan of this center, "To the future with values," is based on overcoming obstacles to moving towards a goal with leadership, wisdom, and transparency using innovation. So this center also includes a concert hall, library that is magical because we all are inspired with the wisdom of knowledge that we are doing as a space pioneers. We always dance with the nature, so we want to explore nature in all aspects. However, the most natural disasters are the long-term results of our actions as we dance with the nature. We use many technologies when examining the disaster and trying to take precautions. And these technologies mostly emerge from the space exploration. If you remember, the two powerful earthquakes hit parts of the Turkey and northern Syria within the space of 12 hours, destroying hundreds of buildings, claiming more than 8,000 people have been rescued over the 12 different provinces. The United Nations, World Health Organization, and many other international actors helped millions of people to most devastating earthquake in Turkey's modern history, as well as the Syrians across the border in the northwest. So, Disaster Management Authority in the Turkey identified precautions due to the magnitude, intensity, local geology, and many other aspects in planning used in constructions. And images taken from the Earth observation satellites were significant to identify all these data for us. After the earthquake, the electricity was cut off for a while. There was no access to cities. And these were difficult times due to the cold weather conditions. That's why space technology supported us a lot during these disasters. So I personally supported the earthquake in various aspects, and it was a situation that affected in my life and changed my life perspective. And people were united only to help the people who were in the emergency zone. And all the museums, stadiums were changed to collect the packages to send to the field and to support the people. I also personally helped people in the field as well as the packaging in the big stadiums and the museums. So as someone who is active in the space field, I thought we should talk this topic at the IAC 2023 here in Baku. So that's why, first of all, I would like to thank both the selection committee, IAF Secretariat, and especially Alessandra and Constance helped a lot during this communication, and also the Azer Cosmos to support this panel. So today we have very distinguished panelists among us. They kindly accepted my offer to be in the stage and inspire all of us in this critical topic using space technologies to support the natural disaster. So first, I would like to introduce René Grispa from Planet Labs. He is the sales representative in the Central Europe and Commonwealth of Independent States countries. René has long-term experience in consulting the companies in the space applications, and he also supported the disaster response in Ankara. Please applaud René. The second panelist, Ms. Daria Stefanova, founder of CEO of Aermo Company, which is ESA-supported company, and by using her startup, he supports the small satellite technologies tracking greenhouse gas emissions. And please welcome Daria. We have the most significant space influencer and space marketing person, Remco Timmermans, with his own agency called SpaceSite EU. He supported us a lot, especially as a member of European Association of Remote Sensing Companies. Remco is ambassador for the use of Earth observation data for applications on Earth. Last but not least, Mr. Luca Deloro has more than 15 years of experience in United Nations. Especially, he is the Chief of Disaster Risk Management and the Climate Resilience sections of UNOSAT, United Nations Satellite Center. Luca. Okay. So thank you so much, everyone, being here. And I would like to remind you, we will use Slido application. You can check these two small screens. Please download Slido application. And at the end of the panel, we will accept your questions for the panelists. Thank you so much. So, I would like to start with Rene. Rene, we met before the panel, and you shared your experience that you visited Ankara after the earthquake. So could you please share your actions in Ankara, and how was the situation when you arrived there?
Yeah, hello, and good morning, everyone. So, when the terrible news reached us that an earthquake hit Turkey on the 1st of February, our emergency response team, so we have a collection planning team, immediately started to collect imagery with the help of our high-resolution satellites, because we know in such situation, having fresh, up-to-date information is the key for any decision-making. And when we came into the office, let us say, we decided, okay, when an earthquake of that magnitude with that impact to the people itself, let's go there and help the people in place. In place means I have not been in the disaster area itself. We have been in Ankara, helping the Ministry of Interior and AFAD, the emergency response team, in giving them access to our imagery. And there was a whole team of Planet behind us working in the premises in order to task the satellites to get images on request. Wherever the team had a need for fresh information, we tasked the satellite to get them the next day or next morning a fresh image. In order to help them take the right decisions, make it faster, the response, and get help to the people as early as possible.
Yeah, that's totally amazing, because just after the earthquake, all international actors try to help the people by using technology, space technology. And did you face any challenge during this process, or what can you see about to improve the things on the location to making these image processing? Because I will also make a transition about technology, because after talking with these challenges, what are the most important technologies we can use to reduce the to reduce the processing time or support the image processing to contribute to early warning systems?
Yeah, it's a very good question. Of course, time is critical, especially in such disaster situations. And whenever you can speed up processes in extracting information from the imagery, it's most welcome. So we have made all the efforts to reduce the time to provide the images from taking, downloading, pre-processing, and providing it to the imagery. But nevertheless, it takes a few hours, so it's a process we cannot really speed up things. But where we can do a lot more is in the processing and extraction of information from that. So we applied a number of processing changes to extract or to distinguish buildings from damaged, non-damaged buildings, to find houses which were not known to the people on the ground. Means every house may have potential casualties in it. And so there's a machine learning process which detects automatically all pixels covered or which covering housings. And this information was all provided to the emergency response team. We gave them access to the imagery, their own new imagery, set them up as users on our platform, on the Planet platform, so they get immediately access to not only imagery, but also to pre-processed results, analytic results of the imagery.
Yeah, that's really thrilling to hear these actions from you. Thank you for enlightening us, Rene. Thank you. Daria, so you are here as a voice of young professionals. So you have a startup supported by European Space Agency. And how do you envision leveraging a remote sensing application in the wake of natural disasters such as Turkey, Syria earthquake? Can you share your experience?
Yeah. Good morning, first of all, and thank you for the invitation to the panel. It's really great to be here. Second, the earthquake is the earthquake that happened in Turkey, Syria. Early this year, once again, showed that we do not have systems in place to detect and predict such disasters early enough. And we as a space community indeed need obliged to think how and what we can contribute to build the detection systems. Satellites and Earth observation technology gives a beautiful opportunity to map certain areas around the globe on repeated basis, depending on the number of satellites, of course. We can change the latency and the period where we observe the areas. And if we set certain markers in the certain areas in the Earth where disasters are very likely to happen, we can learn about how the terrain is behaving and make certain conclusions and try to predict them. Here I will step back a little bit and share, first of all, what we're doing at ERMO. We're building payloads, which is micro LiDAR combined with shortwave spectrometer to deliver information about greenhouse gas emissions. And even though our first application is to support oil and gas companies to measure their emissions, we indirectly touch the application of monitoring emissions and accidents in the area of oil and gas. Talking about evolution of our payloads and how we can use micro LiDAR for emergency and disaster monitoring, altimetry is a very, very interesting technology that can support us with using cameras and visual spectrum. So using these two data sets together can help us learn how terrain behaves, and in that way we can possibly understand what's going to happen in the future. Plus, after the disaster has already occurred, micro LiDAR and measuring the height of the terrain can also support in assessing what's the damage and how to access certain areas quicker.
Yeah, that's perfect to understand all the technologies and innovative approaches from Daria and Rene. So I will just switch to the topic, asking Daria to international collaborations. And you are in a startup and space agency supported. So how do you perceive the potential collaborations between the startups and agencies, space agencies, to support the governments during these the emergency responses or natural disaster?
Yeah, that's a very good question, and indeed we should find as many ways as possible in between governments and small SMEs and startups how to work together. The first and very obvious example is in any kind of support that governments and agencies can dedicate to startups. This gives a lot of credibility in what startups are doing, already pushing small companies towards expanding and towards getting credibility to work with other companies. And what startups can do in return, quickly adjust. Startups are quite agile and quick in adjusting to new use cases, and in case something is really critical, it quickly and leanly align to the needs. Here is another angle where the collaboration can go together.
Yeah, thank you so much, Daria. Thank you. What you do is both motivation and excitement for all young professionals. And so after technology and international collaboration, so if we use the emerging technologies like a puzzle pieces, it's important to establish a strong building blocks. So building infrastructure comes from the transparent communication, which is really important for all experts and all actors in the space. In parallel, Remco, you follow almost all the space activities and you are in touch with all the space actors. And you are actually the middle of the communication to create a transparency. And what does space community need to do to establish these building blocks in the field? So what gaps you see personally based on your experiences, such as technology, policy, or the collaboration that we can transfer to the natural disasters?
Yeah, thank you for that question, Ozan. And you used the word puzzle pieces. This is a massive puzzle. And this is a puzzle that needs to be solved very, very quickly after a disaster has arisen. And unfortunately, there's still many gaps, but we are working very hard in the industry to bridge those gaps. One of the key gaps is that we talk a lot about space data. And space data is not what these rescue relief teams and authorities need. They need actionable information. And the step to take space data, combine it with in situ data, combine the different sources of data. We talk about optical imagery, we talk about SAR data, we talk about in situ, to bring that all together into actionable information that is readily usable by rescue relief teams on the ground, be it ambulance services, the military if needed, fire brigades, all sorts of rescue teams that need information to win time. So that is a major gap. Then another gap, another set of puzzle pieces is the many different actors that we have. We have public data sources, Copernicus being a big one in the European Union. We have private players, like we have here on stage, that all provide different sorts of information that need to be combined, and all these actors need to work together. Now, luckily, we have systems in place. Copernicus, EMS, Emergency Management Services, is a good example. UNOSAT is a good example. UN SPIDER, the Disasters Charter. There's several initiatives to bring these building blocks together very quickly. But the most important gap that I still see is an awareness gap. And that's where I play a role as a communicator, an awareness gap with authorities, with these rescue relief teams about the fact that space data is available and is there to help. Are we there yet? No, I think we see a big development at the moment, especially in the area of turning data into actionable information. Artificial intelligence is going to help a lot, and I'm sure that my colleagues here from Planet and Daria as well, and you as well, are all too aware of these gaps and the possible solutions that we have.
Yeah, you are totally correct about, we need to improve this communication between the agencies, industry, and all the space actors. And new technologies we will discuss in the second round, such as artificial intelligence or new approaches from the companies. It will be really amazing for us. So when you first checked the news about the earthquake, what was the first reaction that in the space sector we have this missing gap, and if we improve this technology we can use in this Turkey earthquake? What was the first reaction in your mind during this situation?
Yeah, the first reaction, well, of course, it's a human reaction. Yeah. It's like yourself. It's every time this happens and we read about the loss of life and the loss of property and the loss of infrastructure, that is always a blow. And with climate change, these things unfortunately happen more often and more frequently. So the first reaction is always a human one, but the professional reaction in a way is then to see how quickly we can activate these systems. How quickly can we activate Copernicus, EMS, the UNOSAT, the Disasters Charter, etc., and how quickly can we get the information to these teams? And you say, can this technology be used to prevent disaster? Well, preventing is probably one step too far. Of course, space technology cannot prevent earthquakes. That is unrealistic. Can we monitor and minimize the loss of life and damage? Well, we're getting there. I'm not saying we are there, but can we support disaster relief efforts and emergency crews? Yes, absolutely. It's just a matter of time, literally. The time for the information to get to the relief teams needs to be minimized. And again, the rest of the discussion that we'll have later will tell us a little bit more about that.
Yeah, definitely. So we take the technology from the international space actors and combine with the importance of the communication with Remco. And now, Luca, actually, you are actually one of the people here who are in the middle of the commercial sector, space agencies, and the all space actors from United Nations. So because in times of natural disasters and global event, you represent the important institution comes to everyone's mind first in the world. So can you explain what was the role of UNOSAT during the situation of Turkey? What was your first action and role in this situation?
Sure, thank you very much. As the chief of the disaster risk management and disaster risk management and climate resilience section, I did the emergency mapping service, which is a 24/7 operational service that provides satellite image analysis and satellite-derived product following major disaster events, complex emergencies, and crisis situations. I was not deployed in Turkey because then our service basically provide image analysis support from remote, from our offices in Bangkok and in Geneva. And of course, a few hours after the earthquake, we've been activated by the first earthquake, the 7.8 magnitude earthquake. We've been activated by IFRC, by the International Federation of Red Cross, and by the United Nations Office of Coordination of Humanitarian Affairs. And then, of course, in Turkey, the coordination and response was mainly led by AFAD, the National Disaster Management Authority. But in Syria, the situation was much more complex, I would say, much more challenging because of lack of national capacity to coordinate response, lack of coordination, and especially there was a big challenge with the humanitarian access. So in Syria, we remember that there were 12 years of conflict, and right before the earthquake, there were like 15 million people already in need of humanitarian assistance, and 7 million internally displaced people. So we've been asked, UNOSAT has been asked to, since the earthquake, of course, doesn't see any barriers, we've been asked mainly to focus on Syria to estimate the level of damage, especially because of the lack of information in this area.
So how much time does it take to do you access to zone by UNOSAT time? How much time does it take? Like, do you access the zone in a few days or by UNOSAT time to go to the Ankara to support Ankara?
No,
how was
as I mentioned,
process,
that we that is also the the beauty of remote sensing and space technology, that we can see things from remote. So basically, once we collected the images, we were able to assess areas that were hard to be reached. So we did all our analysis was done by our offices in Bangkok. So we've been, no one from UNOSAT had been deployed, but we were absolutely in coordination, in close coordination with the United Nations country teams in the field that were actually giving us what were the priority area of interest for analysis and what were the operational requirements of humanitarian actors in the field.
Okay, yeah. Really, thank you to understand the role of the UN in this situation, because you are in the middle of all the communications, and so now we are in the phase of going to a bit deep on the technology side. So Rene, I want to turn it to you again. Specifically, what technologies such as AI or software implementation you use in the image processing, or what do you need to be improved technically to act faster, such as early warning system? I read some reports from your side, and you are collaborating with different institutions such as Microsoft. So can you a little bit explain about your process?
Yeah, it's of course a very complex question. So applying AI to imagery is, I think it's a great future technology, and we are at the very, very beginning of that development. But especially with regard to the imagery and for the earthquake response, we have been in close cooperation with Microsoft, and they have a project AI for Good. Means where they use their own computing capacities and the intelligence they have in house to apply that to imagery and to extract, for instance, in this case, a layer of building damaged and non-damaged. Yeah, means to give a hint for the rescue troops on the ground where to focus their activities to. And this technology was actually developed for other crises in Ukraine, but then could be easily adapted to a natural disaster case like Turkey. And again, you mentioned that the capacity in-house or in the country are limited, and the more sophisticated products we can provide to them on top of the visual analysis, it helps in taking the right decisions. And yes, Planet having a daily data set for the entire world, so we have a very good documentation of the situation before the earthquake, or the day before, and also for the days after. And we have all the means to do a comparison between or a change detection. So what has changed during the earthquake? And based on these change detection, the rescue troops on the ground may focus on the one or the other area. And yeah, I have to say, I heard a lot of accusations and blaming that the government of Turkey is not doing or the disaster response is too slow. I cannot confirm that at all. It means it is a huge disaster area, and the people on the ground were really, really engaged and working around the clock in getting their head into the situation and finding out where to go first and what to do. But what roads are accessible, also in AI technology, see what roads are still available, what's the situation on airports, on bridges, and so on. These are all logistic information which you need to collect first before you can send in the rescue troops and so on. And it takes time. Unfortunately, it takes time. And I can tell you, so with the help of artificial intelligence, we really try to bring that time gap, or means the delay or latency, down to hours or so instead of days. But currently it's still needed. And it's one of our focus research things together with partners like Microsoft to apply newest technologies to a data source like imagery, which has a lot of information content, and to extract the needed information and provide it in a human readable form for the people who need to take decisions.
Yeah. Of course, all the brainstorming we have here, it will take us to one step further to impact on the technology and the collaboration. So Daria, by the support of the ESA in your company, what new technologies or specific innovations you can have based on experience? And can you have some suggestions to new entrepreneurs to be active in this field?
Thank you. Yeah, supporting the last reply. Yeah, indeed, AI has just a landscape of applications and topped up with different sensors and fusing different data sources. There are just really many applications and really many new things we can do. On top of that, brain processing on the satellites can definitely expand the volumes of the data we can extract information from. So these are very, very promising drivers that can really give us much more understanding that we can extract from Earth observation data. And answering the second question, suggestion I can give to young generation is to take ownership, take responsibility, be open to challenges, and try out different tasks. That's first one. And second one is mix technologies. Try to look for creative, innovative solutions on the edge between different technologies. Yeah, this will definitely help us in such an important application such as disaster monitoring.
Yeah, definitely. All the interdisciplinary approach, as Daria mentioned, is really significant in the space industry. You can be a mechanical engineer, but your approach in the software or can support the image processing and so on. So it is really significant. So for the round two, Remco, so you mentioned before all your insights about the topic, and as a space industry communicator, what is the role of space media to support the space industry in developing applications for disaster management?
Yeah, well, thank you. I basically answered that question in the first round because the biggest gap that I see is an awareness gap. And the media plays an important role in helping fill that awareness gap simply by publishing about it. The power of storytelling. And there are millions of stories during these disasters that are sometimes very sad, but sometimes also very hopeful in the way that, in our example, space can help these relief efforts. And I think these stories need to be told better. UNOSAT does great work, just to pick on you as an example, does great work, but not many people know about this. Not enough people know about this in governments, let alone in the general public. UNOSAT is not very well known. And that's the same for Copernicus EMS, that's the same for UN Spider. All these examples are not very well published. So using the power of storytelling, something that journalists and communicators do, will help there, simply by publishing about it. Help create awareness with authorities, with the general public, that these facilities, that this infrastructure exists. And then another thing that is used more and more, this is something really new, is data that is provided on the ground. We now use social media, all of us use social media, and during these disasters we see people posting about what's happening to their lives, to their family, to their specific situation on the ground, posting pictures on social media, assuming that the communication infrastructure stays more or less intact. And we see efforts in investigative journalism, this is the case in war situations, but also in disasters, where this information, geotagged information from social media, is then combined with information from space, from the air, from ground sensors, providing a whole new layer of information, sort of a citizen journalist data source, if you like. One other thing that I'd like to highlight is what Daria just said. When I talk about Earth observation and about space applications, this is an area of big opportunities for people to continue to work on, to use these tools also that you mentioned, René, to bring this knowledge about AI, knowledge from outside of space, data management, and bring space into that equation and help us develop smarter, better, faster applications to help in these relief efforts. So I would really like to repeat what Daria says, a call to all young aspiring entrepreneurs out there who want to help people with the latest tech available. These opportunities are there.
Yeah, definitely. Your highlights are really amazing to flow of this panel. So Luca, during these experience, and you also experienced the other natural disasters, such as we had the Morocco and Libya, the flooding and the earthquakes, because natural disasters are always here. So in your perspective, what are the challenges and limitations encountered in providing support through the satellite imagery analysis in the events such as these disasters? So what do you need from the other players in the space as UNOSAT?
Well, it's a great question. I will answer this question there. First, there are many, of course. One of the major limitation is, I would say that is coordination. Is coordination amongst the different actors involved in response in after disaster event, because we have a multitude. We have many different actors. And many different decision-making process have to be done. In that situation. So, one is the lack of coordination between the space data providers or those providing satellite derived product, because there are a lot of overlapping sometimes. And then there is lack of coordination, and then in a way that how this information is being used in the field to make smarter or more efficient decisions. Then of course there are other limitations, I would say, related to especially in Syria, or if you are now maybe discussing more on the earthquake in the Turkey and Syria earthquake, of course, we have now access to, very high resolution imagery. Technology is not any longer an issue. We have now lots of sensors, lot of constellations. We have plenty of data that can be used and exploited, for many different applications, including, so technology is not an issue. Issue is how this technology, is really informing and being used by governments and those, that have to, take decision, let's say, and do planning. So basically, the other issues that I would mention here is that, of course, when there was widespread damage, we need to do damage assessment, understand what is the level of damage, density of damage, and then you might, of course, accessing pre and post disaster image, very high resolution image, you can assess whether a building, is damaged or not. Now, if you get available, if it was available, of course, building footprints, before, the quake, we can do much more analysis, sectoral analysis, understand, for example, health facilities. How many health facilities has been damaged? Or residential buildings. So if we get, and then those, let's say, baseline data set are often missing or lacking or not completed to be used to provide more insight, not only for response, but also for reconstruction, which is really needed. This is, I would say that is one of the, and then, of course, be aware about this technology. And so that is, it's maybe something that we might discuss a bit later, but I believe that, we have, I would mention these three, as a main aspect that might be addressed, and then, they might be reflected a bit more. But technology is not an issue any longer today.
Yeah, thank you so much. And your aspects really create an awareness in this topic for all of us. So I think we can follow with the questions in your side. And before finishing the panel, I will ask the panelists the last words. But first of all, you can use the Slido application and you can state your questions there. If you cannot use Slido, I believe we have 2 microphones here. Our colleagues will help. Just shake your hand. Our colleagues will help you. I will start with the first question in Slido. So from Miss Adele, are there any possible warning signs of a preparing earthquake which can be trusted and monitored from space? So maybe Rene or Daria, you can give a word on that.
Yeah, unfortunately, there's no secure technology or so which can really predict an earthquake. It would be great if we have been a possibility to see signs of an upcoming earthquake before, even if it's only hours before, so it would help. But unfortunately, not yet. So there's no technology in place which can do that. The only thing are monitoring stations on the ground, seismic stations and so on, which may have a kind of predictive information. And there are a few ideas how to use space for it, especially in, I heard it after the Morocco earthquake recently, so there are some signs that in the atmosphere some predictions or some pre-signs are available, but it's in kind of a hypothesis at the moment which need to be checked. If so, we would be so happy that we have a tool where space data can be used to predict earthquakes. That would be really great.
Yeah. Anyone wants that? Luca? Or, okay.
I can add, yeah, absolutely. Yeah, support that there are different, although there are different hypotheses on how certain technologies can assess this, just, they're not in place yet, and there's just not enough data. We have certain hypotheses how to use LiDAR technology to assess the altitude and change in altitude, but our data sets are quite limited to make the strong statement here. And this is a hypothesis which we're going to test once we launch the satellite. But indeed, there's no reliable space-based system yet.
Yeah. Thank you so much. So there is one quick question related to this first one. You can maybe quickly add that the delivery time of the image from the satellite to the ground station or to make the analytics. So is there any possibility to change that, or specifically what AI tools can be used on that? Maybe Rene again.
And that's a very good question. And yes, we have the possibility to decrease the time significantly. But there are 2 aspects of them. One is the technological aspect, that we need to download the data from the satellite and make them available to the end user. And we are currently in preparation of a new constellation of satellites which have a direct downlink, means the image will be taken, and in minutes from that, using geostationary telecommunication satellites downlinked to Earth and made available in about 20 minutes or so to the end user. That will be a big step forward. But the second aspect is we need to know where to deliver the imagery to. So usually you have an administrative process, even the International Charter for Emergency Response and so on. It's a bureaucratic thing. And in fact, the case in Turkey showed that, and the second day when we arrived, and there were only 2 images available at that time. And it's not blaming somebody that it takes longer, but there's a process behind that. ESA has to task different satellite providers. They will take the imagery, and ESA will collect it into the Copernicus Emergency Response System, provide it to the troops on the ground. It takes time. And that's why actually, what's the reason why we decided to go there and give them direct access, not via the emergency response service of Copernicus, which we anyway deliver the data to, but give them direct access to our archives, and that data can be used immediately when they appear in the database.
Yeah, and that actually came a question in my mind. We have an earthquake, and we have also flooding, water management, the forest fires. We have plenty of the disasters we all face every day. Which situation you are most in challenge in these applications?
So we mentioned already, one challenge is the weather condition. So if you have an optical satellite, it's always difficult to image through clouds. In case of wildfires, you have the additional visibility problems at night and with on fires. But then the more satellites we have and the more flexible we are in the acquisition time, usually you're around the midday, and so the more imagery we have, the more information sources we have for making a decision. And I think that's the way forward. So to step away a bit from only sun-synchronous orbits, but using satellites in inclined orbits, so they have different imaging times over the course of a day, in the morning and the afternoon, so 5, 6, 7 times per day, so to get always an updated image about the disaster situation on the ground.
Yeah, you are totally right. The daytime or the night shift is really significant, and when we see the natural disaster, we need to be there immediately. So that's why all these talk here will create an impact on that. So I would like to ask, do you also have any questions from audiences? You can shake your hand, and there is one from here, Miss Stacy. I see Stacy here.
Hi, I'm Stacy or Anastasia, and I have a question. So if Dasha has a satellite, then ESA receives the imagery. How does REMCO get the information? Because so far I have not heard of a source which is going to tell the people about what's going on. So where do journalists and communicators take information in case they need to tell something to the general public?
It's a bit difficult to hear your question here on stage. It echoes a little bit, but I think I got the gist of it. Is how quickly is this information passed to journalists? Is that what you're saying? Or say it without microphone.
What's the mechanism of communicating the satellite data to the general public? Because maybe countries will have satellites, right, in different areas. What if one satellite finds something out about a different country? So how do the countries find out about that information? Is there going to be a governing body? And how does the information get from the governing body to journalists, etc.?
Okay, let me give the short answer, and then perhaps my colleagues can give a slightly longer answer. I don't think it is important that the information gets to journalists very fast. I think it is important to get the information to the disaster relief teams first, and then journalists will develop stories based on that. But it's critically important that the information gets to, well, I suppose to you, Luca, as soon as possible.
If I understood correctly, the answer is also the question about satellite. We can access now many different sensors, many different missions that are launched by different countries, different governments. So satellite acquire information everywhere. So it's not a matter of which satellite and where, but it's a matter of analyzing this information and sharing this information with those that need then depending on the application, there are commercial applications that are for businesses, but then talking about humanitarian assistance, of course, this information has to go to the right people at the right moment. It's vital that the information, comes quickly to those that have to, take very, very quick decisions. So ours days are in an emergency response context extremely important to save life and to make sure that people are, put in safe conditions. And then, the something very, very important also to say that was mentioned by colleagues here is that it's not the data itself important, but it's how this data are analyzed. It's basically what people need are not the data, accessing satellite data, but it's accessing, the right information from those. And this information is extremely important to be, and then maybe we might need to have also to emphasize a bit more the importance of communication and making sure that people understand and knows how to, make the right use of this information.
Yeah, thank you so much. And we have a question from Mr. Bernard, and after Bernard, there is a gentleman here in front. He will ask later on. Please, Bernard.
I'm Bernard Frank, former ISA, and also now we have a platform to train entrepreneurs and researchers. So I would like to follow on Daria's proposal. I want to advertise that, okay, you can do some work at the level of satellites, but data, but also services, how you use data. And you have many ways to use your creativity for that. One example, we had a company that developed, it's called Blackshore, Cerberus, that developed a game for people to find features on Mars. Okay, and then he went through the ESA big system, and they created a company to apply these games to disasters. And so they invite the public to identify after disaster what roads are still available, and then this you can be communicated to the authorities. Now, even further, they have worked with the AI universities to teach the machine to do what the crowd can do. So you can use your creativity, use the new tools of machine learning to develop also solutions. So I think I would invite all of you, if you like games, if you like data, or if you like hardware, there is really a lot of things that you could do as a startup of services.
Well, thank you, Bernard. That's a very important call that I think Daria mentioned, that I mentioned, and that can't be said enough. So thank you very much for your remark.
Yeah, thank you, Bernard, with your experience and so on. Thank you. So please, the gentleman.
Good morning. Just I have one. I want to know what is happened during the Libyan flood. It's anybody can make the comment. It's a failure of communication. It's a failure of any observations by the satellites, or it's a failure of response. So it's because we have the very good satellites for flood monitoring, like Sentinel and other synthetic aperture radar, but its use needs to be huge failure. Just I want to know it's a technology failure or it's communication. Thank you.
Yeah, thank you. Maybe Luca, you can comment on that.
I can answer in this way from what as far as I'm concerned. We've been activated for Libya floods by the United Nations Office for Coordination of Humanitarian Affairs. So basically, our emergency mapping service, as I mentioned earlier, works upon a request. So as soon as something happened, we might be requested or not, or activated or not, because maybe certain countries, they have absolute response capacity, they have their own capacity in doing any type of satellite image analysis, so there is no need to have any either international humanitarian assistance or to have any satellite image analysis support. Case of Libya floods, UNOSAT was actually the first organization, and we look into, as soon as we've been activated, there was availability of imagery, and then we were able to basically delineate, the area affected, and then, estimate the number of buildings affected. But then, this is a work done in the response, so as soon as something already happened. So what you're talking about is basically all the entire monitoring and then, let's say early action is what we call, it's very important now now there are many initiatives towards this, what we call anticipatory action, so, and also early warning, but this is something that has to see with disaster preparedness, as full responsibility of the governments and then that is one of probably of the major issues, is basically how we can really, increase the capacity and ensure technological transfer to those governments in order that they can handle and they can face this disaster event. So international community can only observe, but then, in Libya there was not the situation because of the political situation, of course, there was no any kind of monitoring system in place.
Yeah, thank you so much. I hope these information and insight helped a lot. Yeah, please go ahead, gentlemen.
Hi, thank you very much. Firstly, Obad El Shahade from Turkey. My question is talking about the problem, which is maybe the communication or other problems. How could the countries that doesn't have satellites benefits from the data, or how can we communicate this or deliver this information to these governments or to these dire risk management teams in that country, because they don't, as we know, that they don't have satellites. How we can deliver? I mean, what is the protocol that they use or now that has used by the teams or by the teams who is working on satellites and data? How this communication that becomes?
Thank you. It's a great question. How the mechanism works to deliver images to countries who doesn't have the satellite and who doesn't have this potential. Maybe Rene and Luca, you can support us.
I'm happy to answer that question. Of course, there are many countries in the world who doesn't have satellite capacities and they have to rely on existing satellites from other countries. So happily we have organizations like the International Charter where the image providers, I think every image provider oblige themselves to provide imagery for humanitarian aid. So there's just a process that the International Charter needs to be activated, and then people start, or the companies start delivering data into it. And that brings me back to my previous statement that it costs time. And so there is a process in place, but it's always a bit of delay. The other aspect here is that most of the satellites, especially the very high resolution satellites, which are so important when in these cases of 50 and 30 centimeter resolution, are in private hand. So, and as a private company, you always have these questions. So actually you have to do business and you have to do humanitarian response. And that's a question to be decided in every company separately. So we at Planet, we have the policy, whenever something happens, any commercial things step away. Means there's a highest priority in tasking, so the tasking system itself will always task first satellite imaging process over disaster areas. And the second aspect is, of course, we have contracts to fulfill and so on, and we ask our customers also to step back. Means wait, can you please wait for 2 or 3 days to get your ordered image in order to fulfill the requirements for a disaster case. And I can tell you 99% of the customers agree to it. So everybody is in the same phase and say, yes, of course, we can wait. And we are happy to do from our side, from the internal processes as a satellite image provider, to speed up this process by having a collection planning team which is available around the clock, which are scanning and getting the news if something happened, and they start, we call it speculative tasking, means they probably know that these images will be required, and we task the satellites to go over to the area and get images as soon as possible. And that brought us into the position, especially for the Syria and Turkey earthquake, that we had already imagery available on the second day and could provide to the people on the ground.
Yeah. Anyone wants that? Okay.
So maybe I can add and build on what René said. That it's not important whether somebody has a satellite or not. As I mentioned also earlier, it's important that this UNOSAT, the United Nations Satellite Center, we only use and get access to commercial satellite images. So anybody can buy or can get access to these images, except, for example, in the case of major disaster events, that imagery, there is this International Space Charter. The International Space Charter is basically an agreement between 17 space agencies that in case of major disaster events, they made all imagery acquired in a disaster situation available only for authorized users, that including UNOSAT and other satellite mapping groups, of course. And again, it's very important that imagery, the access to raw image is not probably important for governments. They might not have the capacity and the time to spend on doing satellite imagery, because there are agencies or mapping groups that can do the analysis for them. But they have to receive, what are important to disseminate and to share is the information, the information that has to be provided to the right people at the right time. And then that is, it's very important to be clarified, I guess.
Yeah, thank you. Go ahead, Remco. Thank you.
Yeah, one short remark in line with your question, but also in line with your question, is that the distribution of activations, and I did some research into Copernicus EMS, so I cannot speak for UNOSAT, but the distribution of activations of the Copernicus EMS rapid mapping system is not equal. We see a very big emphasis on the developed side of the world, European disasters mainly. And this to me, because Copernicus EMS works globally, any authority can activate this rapid mapping system, but that doesn't happen. And that to me is an indication of the awareness gap. So it doesn't really matter whether a country has capacity in space themselves or not, because satellites orbit the entire globe. But it's the awareness of authorities in African countries, in Southeast Asian countries, in Latin American countries that is simply less than it is in Europe. So again, this is a communication thing, and that is the role of my community, I suppose, to, again, tell the stories, making sure that these stories are told also outside of Europe. Copernicus is a European Commission initiated system, but is available everywhere, and that should be known everywhere. And that is something that's not happening right now.
Yeah, thank you so much, Remco. And regarding all the questions, actually, I want to add just two quick remarks. That International Disaster Charter, we haven't mentioned the action of the International Disaster Charter, but the members of this charter, such as CNES, Canadian Space Agency, and many other institutions all around the world, provide support all the emerging countries. And also the one important thing is the education. While I was preparing this panel, I checked some databases that NASA has an education tool called RSET. It is a tool that you can have a free webinars by using the remote sensing applications of NASA. So these are important aspects you can follow. I think we have time for one last question. Please go ahead.
Hi, Hatice Müberragül by T3 Foundation from Turkey. In Turkey, when the Turkey earthquake happened, the government reduced the bandwidth to prevent false information, fake news. What else can be done to prevent these kind of false informations? Like, what can be the solution for these from the media aspect?
Okay, I think the question is during these disasters, the bandwidth reduced, right? And what can be done to improve these bandwidth situations and so on?
Or instead of reducing the bandwidth.
To make the better data flow. Yeah. So we can maybe finalize the final remarks and answering your question. Rene, what can be done to improve this data flow during this emergency? And you can add quickly, and we can ask all panelists the final words to finalize the panel.
Yeah, the quick answer here is to use as many as possible information sources and combine them, and make sure that the information reaches the right people on the ground, means in the disaster area, that they have a tool for right decision making.
Please, Rania, final remarks.
Following up and develop technologies that enable data processing, feature extraction faster and in more optimized way.
Mr. Remco?
Yeah, real quick to answer your question, space can help in places where bandwidth disappears because of disasters. We see Starlink, OneWeb, telecommunications solutions from space can help there. And my closing remark, again, is all about awareness. So let's keep talking about this, let's keep sharing the stories about how space helps, and make sure that as many people as possible know.
Yeah.
Also, maybe if I can run my last
Last words.
remark is really, as I mentioned earlier, and then believe me that I've been in this business for 15 years, and then, the space industry made, tremendous progress. I remember years ago there was always, question about, we need more data. Now there's no longer need of more data. We have all the technology we need, and then, talking about my business and then what I'm doing, but in disaster situation, especially when major disaster occur, we need really to bring to the basic, to provide the right information in the right moment, because this can really save life. And then technology, it's we have all what we need. We just need really to mainstream and then make sure that communication and then that increase the capacity and then invest in disaster preparedness is still really the priority, and ensuring the proper technological transfer to those countries that are prone and then probably more vulnerable to disasters and climate change. That is probably what we know as the UN we are trying to achieve with capacity development.
Yeah, thank you so much. So with that, I would like to thank all of the panelists to being here to support us with their valuable insights and experiences. I would like to thank you for this interactive panel, asking the questions and listening us. Please do enjoy the rest of the IAC. Meet the people, share your imagination, and please don't hesitate to communicate each other. As the Remco mentioned, we should communicate with transparency to support our future. Thank you so much.